All right, here's the 2019 AB number 3. So they give us a continuous function defined on that closed interval from -6 to 5. The figure shows a portion of that graph. It has a couple line segments and a quarter circle with the center of that circle at 5, 3. It's known that there's an ordered pair at the point 3 and then 3 minus root 5 is on the graph of f. So for part A, they say if the integral from -6 to 5 of f of x dx equals 7, find the value of the integral from -6 to -2 on that. So what I would do is they give me the graph from -2 to 5. So I want to try to partition this out somehow. So in my mind, I see this integral that they gave me, and I can break it apart at -2. So basically all of the stuff up to -2, and then from -2 to 5, I can think of those in two different chunks. And so the first one, -6 to 5, the total they gave me is 7, which is good. They didn't give me this middle chunk, this -6 to 2. I'm going to have to, that's what I'm solving for. And then I can figure out this -2 to 5 business, this f of x. And that's just finding the area underneath the graph of f, maybe a little bit above, a little bit below the axis. So I just got to use a little bit of geometry and see what that number value would be. So I just do a little bit of shading. I think that those two triangles cancel each other out. The first one, area of a half, and then the second one's negative a half because it's below the axis, but they're gonna wash each other out. The next little two triangles, I think, also wash each other out. So really what I have to find is the area of that trapezoidal looking thing. That area is 2. The one block is 1, and then we can just find the area of that triangle with base times height. The challenging part on this one is finding the area of that shaded region right there, because they don't give me the exact function of that, although we can figure it out. But I'm just going to use geometry. So I'm going to find the area of that whole rectangle, square, and that's 9, and then I'm going to subtract out that quarter circle. So the quarter circle would be pi r squared with a radius of 3, and then divide that by 4 because it's a quarter circle. So if I mash all that together, it looks like I get 11 minus 9 pi over 4. That's the value of the integral from -2 to 5, and then I can just move that stuff onto the other side. So I'll subtract the 11 and add the 9 pi over 4, and that will give me the value of the integral that they're looking for, which is just 9 pi over 4 minus 4. And for part B, they want me to evaluate the integral from 3 to 5 of 2f prime of x plus 4 dx. And so we have a couple options, but I'm going to go ahead and use some of the properties. First one is if I'm adding components in an integral, I can give each one its own integral. And the second is if I have a scalar coefficient, a multiplier in the front, I can just move that to the front of the integral. And so I'm going to rewrite this integral first as 2 integral from 3 to 5 f prime of x, and then plus the integral from 3 to 5 of just 4. So I split that apart. Then I'm just going to do my antiderivatives for this. So 2, the antiderivative of f prime is f, and then the antiderivative of 4 is 4x. And then I can just plug in my upper and lower bounds. So I'll plug in the 5 and the 3 upper minus the lower for both of those. So 2 f of 5 minus f of 3, and then plus 20 minus 12 would be the 5 and the 3 plugged into the second one. So now I'm just going to use that graph and see what my ordered pair values are. So 2 f of 5, if I look at the graph right here, f of 5 is 0. So that first part is going to be a 0. And then f of 3 is actually the ordered pair that they gave me right there in the beginning, and that's 3 minus root 5. So that's what the f of 3 is going to be. So I'm going to throw that in there. And then plus 20 minus 12 is the 8. And then just a little bit of simplifying. And looks like I get -6 plus 2 rad 5 plus 8, and then 2 plus 2 rad 5. Now you didn't have to split it up that way. You could have just done it straight from the original and just anti-derived both components of it. That just would have looked like this. 2f of x plus 4x. You could do each one individually, do your upper minus lower, and you end up getting the same answer either way. So it doesn't really matter which way you go about it. And for part C, they give me a function g is defined as an integral expression. So g of x equals the integral from -2 to x on f of t dt. They want me to find the absolute max value on that interval from -2 to 5. So for this one, if we're finding an absolute max value, I would build a table. The table would include both endpoints and any critical numbers. So the critical numbers are where the derivative of g, or g prime, would equal 0. Now, if I took the derivative of that antiderivative function, it ends up being just f of x for that. So I just need to set that equal to 0 and see what that looks like. So I'm going to use the graph and figure out where does f equal 0. And it equals 0 at, looks like 3 spots at -1, 1/2, and 5. So I want to build a table with all of those values in it. So absolute max table would be xg of x, just normal table, and then I just plug in both my endpoints, and then any critical numbers in between. And so now I need to find out what those values are going to be. So let's go ahead and find g of -2. So just plug in a -2 for the x's. And if we're going from -2 to -2, you're not traveling at all, so the value of that integral would be 0. If I want to find g of -1, I just plug in a -1 for the x, and essentially I'm looking for the area underneath that curve from -2 to -1, and so I see that value is 1/2. That's essentially the area of this little piece right there. And then the next one would be finding g of 1/2. So that's going from -2 all the way to 1/2, and that would be -1/4. The reason that's -1/4 is because if I start at -2 and I use this little triangle and this little triangle, they cancel each other out. So all that's left is this little triangle right there, and that's going to be 1/4, and it's below the axis, so it would be negative. The last one here would be g of 5, -2 to 5. On f of t dt. We've already found that from part A, so I'm just going to bring that in. That's 11 minus the 9 pi over 4. So we already did all that legwork ahead of time. Okay, so the absolute max value on that is the 11 minus 9 pi over 4. That's bigger than any of the other values, and so that would be the absolute max. And for part D, they want us to find the limit as x approaches 1 on that crazy mess. So the first thing I would always do with the limit is just try direct substitution to see if it works. So I'm going to go ahead and plug a 1 in for all the x's and see what I get. So that'd be 10 to the first minus 3 f prime of 1 all over f of 1 minus arctangent of 1. So we'll see what we get. Hopefully we get a number back and we're good to go. So we get 10 minus 3 f prime at 1 is the slope at 1. So I'm looking at this ordered pair right here at 1, and I'm just calculating the slope of that. And that goes, looks like up 2 and over 1. So that's why I put a 2 there for the slope. F of 1 is the actual ordered pair. F of 1, if I go to x equals 1, the y value is 1. That's just the ordered pair right there. And then the last part is finding this arctangent of 1. So how I think about it is arctangent, that's inverse tangent, tangent of theta equals 1. And then if I built my little triangle off on the side for 1 over 1, that'd be a 45-degree angle or pi over 4. So I know that would be pi over 4. And then we'll just do a little bit of simplifying. It doesn't look like I'm going to get 0 on the bottom or any indeterminate forms. So I think I can just evaluate that as 4 over 1 minus pi over 4. And you can reduce that a little bit if you want, but you're usually good to go leaving it unsimplified.